Steve? I've got the mic. What we'll do is have a quick update on the ROI program that we're doing. Once again, we always like to thank DOE for the grant and for all the research help on the program. Some of the rationale for the study was that a lot of different sites are having a harder time making the justification to their management for acquiring large HPC systems. The average price of an HPC system has gone up dramatically, but in addition to the price going up dramatically for small, medium business, there isn't an easy business case. One of the industrial presenters yesterday was asked the question, why can't you buy a leadership class computer? And the response was, well, until I actually have a run that I can prove that it's going to be worthwhile to my management, I can't get justification. Well, you can't get that justification then until you buy the system. So you've got the chicken and egg. So the intent here was to collect a lot of examples to show hardcore what the return on investment is for HPC systems. And we separated it into two categories. One is financial ROI, the traditional return on investment from a revenue perspective, from a cost saving and profit perspective. And the other side is on the innovation or scientific innovation discovery side of it. And right now in the data structure, we're sitting at, I think, 750-ish, but what we've published is the 673 in total. Now, we're real excited about this from another perspective, is we had certain statistical criteria, and we feel we're finally at a stage that we have enough data points that we can actually start publishing in more regular journals and everything else, which we're just starting that process. So here's just some demographics before I show the numbers. By country, we have fairly good coverage in China, the UK, and of course the US and Japan. And this was which we're trying to populate more throughout. We do believe that you need more in the order of 200-ish per country to do any country comparisons. Now, all this data we make public, so if anyone wants it, I'll show the pointer at the end. And like I say, I just caution people because it's got pivot tables and structure, so you can sort by country, but right now you can see there's only 3 or 4 countries that are statistically sound enough in the data. So by sector, we have about 362 from academic type organizations, 76 from government, and 235 from industry. And here's the finding, which is just amazing to us that it continues to be as high as it is. For every dollar that somebody invests in an HPC project, on the HPC side, on average, they're returning $551 in revenue. And if it's on the profits side, they're returning $52 in profits. Now, this is macroeconomic modeling. So you have an investment here, you have a lot of stuff that happens in between, then you have your results. So this doesn't account for things like building the factory, having a sales force, and everything else. But it's just the comparison, the ROI of that investment. And these are far higher than what most venture capitalists ever require and everything else. So it's a very strong story. The other thing in the data structure, we do have all the different examples. So if you need to sort through examples, I did a snapshot here just by industry to give a feel for the different industries. And we're making available the entire Excel data structure with pivot tables, as I mentioned. And these are just snapshots out of the pivot table. But we're also looking at the number of jobs added. I mean, what does the political systems around the world really worry about is keeping your population employed, having a good economy. And right now we're at about 2,300 jobs that were created from the sample. And we're growing that structure. To support this, we're also doing an additional side study to find out how many companies, if they started using HPC, could be more successful. And that's where the job number then we overlay. And eventually we want to get a point that we can actually say if a government invests $1 billion in HPC across, say, 5 industries, how many jobs would that create? So that's kind of the end point that we're marching towards. Here on the innovation side, I mentioned we have 2 different models here. One's on the financial side, one is on the scientific discovery. Here's the mix, and we also split the innovations, whether it's basic or applied. And so in this case, we have right now a grand total of 525 innovations in the study. We then rank them, and we've created a number of indexes. This one is how important the innovation is. Is it one of the top 2 or 3 in the last decade, or one of the top 50 innovations? And the scale's working pretty well. People are spreading it. Then when we look at the impact, how many organizations can take advantage of this innovation? And we've increased the scale to 6 because we had a lot of lumping at 10 and above. And you can see, again, this is still lumping a little bit 5 to 6. Now, in the last half year, we've created an additional index where we've taken both of those and we've created what we call innovation class scale. So Bob Meisner was the one at DOE originally who asked us to create in this project at some point an actual class scale for all scientific discoveries and innovations. And we're not saying this is the best one, we're just saying we're able to collect the data and create the scale. So class 1 innovation is one of the top 2 or 3 in the field, in a given field over the last 10 years, plus it's useful to at least 10 organizations. And you can see how it shifts out. And then across the data structure right now, this is how the innovation class scales look. And what this allows us to do by having this is you can actually, again, we have partially populated, but once it's fully populated, you can compare this by country, you can compare it by industry, by sectors, size of organization also. So there's a lot of search parameters on that. We're also looking at what the typical investment is required for an innovation, scientific innovation, and this scale shows how that works. And the last part that I hinted about a little bit too is this is really on the order of 700 success stories. And we're going through the process right now. We did publish early in the program with the pilot study 18 success stories. Our objective right now is as fast as we can to publish another 100 success stories. And this really more addresses that first objective that I mentioned. For companies, organizations that have to justify a big supercomputer or small, medium businesses that have to justify a machine, they have those success stories in each of those sectors in different areas that would match what they're doing. And here's the website pointer. You go to the regular userforum.com website, which by the way is going to be the Hyperion website too. So if everything about Hyperion is going to be under that umbrella. But if you just put the /ROI and the results, the latest ROI data, we plan to start every quarter just pushing out the new set of data here. And then we'll have a slide deck that's a bit longer than the one I just walked through. And then we're also including the original pilot study here because this explains all the definitions of all the different categories. So that, and the 18 success stories I mentioned, you can click here and get that report. And so in summary on the whole thing, we are still projecting that HPC will be a growth market. Relative to regular servers, we do a lot of comparisons between the whole server market, the HPC market, the cloud computing market. Right now, the difference between the HPC portion of the server market, and if you look at all servers minus HPC and minus cloud, the delta gap right now is 15 points as far as growth rates between HPC and non-HPC, non-cloud servers. So there's a dramatic shift taking place in the market. We do expect the vendor share positions to shift. They did shift greatly in 2015 and 16. We do expect them to shift again. Sometimes a shift is just a merger acquisition. For example, SGI is no longer there, so that's a shift. And then the HPDA market that Steve just hit a few highlights of what we're tracking there. That's really where the major growth is right now. And we do include machine learning, AI, and everything else under that umbrella of HPDA. But that really is the major growth sector that we see going forward. And this chart is amazing to me because I thought it would be solved a long time ago. The machines, the systems are growing in size dramatically and growing in complexity far faster than the software can take care of it. And I'm talking about the system software, the application software, middleware, all the different stacks. I always thought when we first put this chart together, and it's very similar to what we had 10 years ago, the same chart, that within 4 or 5 years we just kind of check a box saying, well, this is so much better, who cares, this is better. The world's going in the opposite direction. Each of these categories are consistently getting worse. And the net, we've been saying that we actually believe that most applications have to be entirely redesigned sometime, and it's actually too late for most of them, meaning they should have been redesigned 5 years ago. But by the time we hit the world of exascale computing, if the applications haven't been rewritten, you're going to be running them on a giant machine as a capacity workload that's only using maybe a fraction of a percent of the machine. So we think that's one area that the whole industry really needs to grapple with. And with that, I think we have a couple of minutes for questions, if anyone has any questions.